there and welcome. We're going to be demonstrating a chemical and physical changes lab. The purpose of this lab is to classify various mixing processes as either a chemical change or a physical change. So when two or more materials are combined, in a physical change, each of those materials retain their original composition. They don't change. So it'd be like if you were making a fruit salad and you mix some apples, some oranges, and some blueberries, every piece still remains the same. When you mix them up, you can still identify and pick out. You don't like the blueberries, you could pick out the blueberries. That's just a physical change. Or cutting something up. Just a physical change. It's still an apple when you chop it up. Now a chemical change is when you mix two or more materials and it creates something brand new that's completely different from either of the materials that you mix together. So a good example is table salt. So table salt is a combination of sodium and chlorine. Now sodium is a metal and chlorine is a gas, and if you come into contact with either one of those, they're very toxic and can burn you, make you sick. But when we mix them together, it turns into table salt, and that's something we eat every day. It's in almost everything we eat. Our bodies need salt. So today we're going to look at these physical and chemical changes lab, and for a special note, it's really important to know when you're observing a chemical change, how to identify that. Now in some cases, as in when you're boiling water, that's just a phase change. We're just taking water and turning it into a gas, but it's still water. It's just vapor. But when we're making, say, when you did the volcano experiment, when we mix vinegar and baking soda, that creates a brand new gas that boils up and that makes it bubble. So the production of a gas, and usually by seeing bubbles or making a balloon expand, would be that. Production of a solid, and in chemistry we call that a salt. So if you're mixing two chemicals and you have it over the Bunsen burner, and all of a sudden you notice there's some kind of material floating around in the liquid or settling to the bottom, that's a solid, and we call that a salt. So it's a production of gas, production of a solid. Those are two signs. The other two signs would be a change in temperature. So if I mix two chemicals together and I touch the container they were being held in where I mixed them, and sometimes it gets really cold and other times it gets really hot. So that would be a change in temperature. Another change could be a change in color. So there are some chemicals you can mix together, and this is what creates fireworks and all the different colors when we see the fireworks in the sky. When these chemicals come together in that explosion, they create different colors. So a change in color and a change of temperature. So those are our four. They're very important to remember. We'll be referring back to these throughout the rest of this class, this semester and next semester. So the first change we're going to observe will just be, well, you tell me. We're going to go and we're going to talk about it as we go along. So I'm looking down on my lab sheet, and procedure 1 is mixing sand, salt, and water. So the directions tell me to place a small scoop of sand. So I'm going to take the sand and I'm going to pour it into my Erlenmeyer flask, and also a small scoop of salt, and I'm going to place that in the Erlenmeyer flask. Next it says to add 10 milliliters of water, and I have measured these out. When you're using a graduated cylinder and you're asked to put a specific amount in, you have to get down at eye level and look at the line where 10 is, and you have to make sure that it's called the meniscus, the bottom of the water. The water actually, the surface of the water actually dips down due to gravity. So you'll have to look underneath to get an accurate measurement, not just the edge of the water here, but where the bottom of that like disc shape goes. So I've already done that. So I'm going to pour it into my Erlenmeyer flask. Now according to the directions, it says then to get your coffee filter and or filter paper, put it in the funnel, in the ring stand over the beaker. So we're going to swirl this around, this mixture of salt, sand, and water, and we're going to pour it right into the coffee filter. So we've got that. I've still got some sand in the end, but we can see that the sand separated out. And we're going to let that drip for a few seconds. And what we're going to do is we're catching the filtrate. This is called the filtrate, which is coming into the beaker. We've caught that into our beaker. And then what we're going to do, I'm going to switch ring stands because we need a different height here. And we're going to get our Bunsen burner ready. And what we're going to do is we're going to place the wire mesh screen on top. And we're going to take the evaporating dish, put the evaporating dish on there so that it doesn't fall through. And then what we're going to do is we're going to take our filtrate here, the liquid that we collected, and we're going to pour it into the evaporating dish. So we'll do this in a couple, we'll examine what our leftovers are here in a few minutes. So then what we're going to do is we're going to turn on our Bunsen burner. So remember, when the handle and the spigot are straight, the spout are straight, that's when it's open. It can go right through the gate. So I'm going to get my fire ready. I'm going to turn on the flame. And we're going to get this ready to go. So this is a pretty nice flame. When you're using the flame, what you're going to make sure you want is, if you look closely, you can see inside the actual outside flame, there's a light blue inner flame. And we say it makes a cone. So when it has a nice cone, and if it doesn't have a nice cone, then you need to adjust by turning this at the bottom. And we've got a nice one going on right now. So we need to get this out a little further. This ring is a little farther away. And what we're going to do is we're going to heat up this liquid. Okay, so we're heating it up and we're going to keep it going. Pretty soon it's going to start boiling and the liquid is going to disappear. So fast forward, okay, so I'm going to pretend that's already happened. So I'm going to turn this off. And then what I'm going to do is, this would be the outcome afterwards. It's kind of like one of those cooking things on Facebook there, where they kind of just tap it with the spatula and it goes right away. So if you want to come over and you want to see what we have left in the filter, we examine the filter. And so what we see inside the filter is just the sand. So on your data table, what you should be recording is what was left in the filter paper is the sand. There's no water left in here. We don't see any salt crystals, just sand. Now, in our evaporating dish, after the water has boiled away, we can see this white crystallized salt.